AASHTOWare BRD and BrR products are part of the AASHTOWare suite of transportation products. They're developed, supported, maintained, and enhanced between several experts from AASHTO member agencies. This partnership, it works out for everyone because it keeps costs lower than custom or individual development. We all get to pool our knowledge and our resources, and all of our members verify and validate the products. We like to say that the software is developed by DOTs for DOTs. Hey Todd, how you doing?
Good.
Thanks for helping out with this.
No problem.
I mean, you've been on the task force for a while now.
Yeah. I was involved with the AASHTOWare bridge rating products back in like 1989, 1990s when I got involved as a user. And our goal at that time was really to create a database of everything you need to do a rating of a bridge, because we thought that was the most expensive part for states to create, was all the data. But over time, we realized that we needed at least one engine to have in the product. So it kind of grew from more than just the database. And now we have an engine and this AASHTO specifications checker. A lot of commercial software that you can buy is really good at doing maybe a design of a new bridge, but they don't do batches of bridges very well. And that's one thing that the AASHTOWare bridge rating, I think, does very well.
So where do you see the future of AASHTO going?
I think the AASHTOWare bridge rating and design, with our modernized software that we're hopefully wrapping up here at the end of 2020 here, really lays the foundation for being able to do things like cloud computing, where we can hopefully do a lot more, a lot faster by using the cloud power. And just our whole new architecture allows us to stay modern and fresh. And I mean, we started the design in about 1995 and we're still using it today. So in the software world, that's a long time to stay relevant and current and usable.
The software gets funding from states and FHWA. Over 40 state, local, and federal transportation departments have had a hand in making this software and keeping it running. The AASHTOWare bridge design and bridge rating systems use a common user interface and database. The agency can store a detailed description of each bridge. Now, this description is independent of the analysis engine, method of analysis, and specification. First, the graphical user interface is used to build the 3D model of the bridge. Second, the database stores a 3D model of the bridge, and this can be either Microsoft SQL Server or Oracle. Third, the design and rating engines can use specifications such as ASD, LFD, LRFR, and LRFD. Analysis, 3D line girder and 3D curved analysis. Fourth, third-party engines can be utilized with the AASHTO product for analysis. And finally, import utilities can pull bridge data in from other sources.
I've used BRD almost from the beginning. I've been working for KDOT for over 30 years. It's been a go-to tool.
So what features do you guys use out in Kansas?
Well, I think some of the most important features are the ability to, once the bridge is coded in, to look at multiple scenarios. We still load rate, load factor design. So that's an option. Design LRFD, looking at different specs, being able to load rate it in LRFR as well as LFD. You do a lot of what if scenarios. You don't have to code the same data into multiple software engine. I mean, you can just choose a different engine, choose a different spec version. So it makes that lots easier to do.
And how do you guys get value from the software?
It follows the AASHTO specs, and it also has multiple versions of the AASHTO specs. So if you want to check to see what changed from last year to this year in the specs, you can easily run the two versions and see what what changed. So that's been good to evaluate changes in specs. We have limited staff with the load rating section, so being able to save time, we just transfer the file to them. They don't have to recode, the whole bridge. So that same database is used to load rate for permit trucks and overweight vehicles as well.
How do you like it compared to other software that you use?
I know some software we've used in the past has been kind of like a black box. It's hard to see where the calculations came from to get there. And one of the nice features in this is every single spec check and all the calculations are available fairly easily to check something. You can see all the numbers that went into the spec check and the calculation.
Great. Well, thanks for talking to us about it. So Michael's calling in next?
Yep.
Okay.
You probably want me to look directly at the camera, or
Yes, sir. That's perfect.
it wasn't until 2009 that we just jumped both feet into the water and started putting all of our bridges in there. We have 99% of our bridges capable of being analyzed in this software. It gave us much more control and just a much greater confidence on how it was dealing with the types of bridges that we wanted to.
How does the software make your lives easier in Idaho?
It allows us to be more certain that the demand over the capacity is accurate. Whereas in the past, we were having to be very conservative so we wouldn't have some kind of a failure. Mm-hmm. AASHTOWare is very responsive in handling any bugs or listening to what the owners need and being able to give either solutions on how to overcome them or solutions on the new software package to enhancements to make it work like we need it.
Hey, Tim, are you there?
I hear you. Do you hear me?
I hear you, but I can't see you.
No, you don't. Can you hear me?
There we go.
All right. How's this going to work?
You are talking about BrDR.
All right, very good. So comparison validation is an important part of BrDR. It allows you to enter the model once, and then you can compare, you can rate that bridge using a number of engines, rating methods, versions, specifications, and so forth. You can rate it using, as I said, different engines to get the results. You can rate it using ASR, LFR, LRF, using different rating methods. You can also do comparison rating between the different versions of the MBE specifications. And finally, you can compare between a 3D analysis and a line girder analysis. And one of them will look at the entire bridge. The other one looks at just a cross-section of the bridge. BrDR is a leading engine for oversized overweight permitting rating. BrDR is able to do dual lane and other non-standard gauge analysis. It can handle unlimited size vehicles. It can rate any number of axles and any number of tires on the axles. The BrDR also allows you to rate with an adjacent vehicle, specs for that adjacent vehicle. And one other important part of it is that BrDR allows you to run multiple scenarios simultaneously. Rating can be performed with multiple scenarios with different impact values, single lane settings, and so forth. This can help you identify when the load can pass at a crawl or other restrictions if it's unable to pass at full speed.
Perfect. Thanks. Superstructure modeling methods. System computed dead load and live load distribution factors. System definition is a method of entering a superstructure by describing all of the girders in the framing plan, including the position of each girder within the overall superstructure. System definition allows the analysis engine to distribute the typical section load and compute the live load distribution factor for each girder. User-defined dead loads and live load distribution factors. Line definition is a method of entering a superstructure by describing just one girder where no relationship between the girders is defined. User-defined live load distribution factors are used for the analysis. Two girder property input methods schedule definition. Schedule-based input is a method of entering data about a girder by listing and describing all of the parts individually. For example, you can describe the web plate, flange plates, stiffeners, and cover plates individually, including their size and position within the girder. Cross-section. Definition-based input is a method of entering data about a girder by selecting a number of points along the line of the girder and describing the cross-section at these points. Typically, the points will be selected at places where the cross-section changes, such as where a cover plate begins or ends. This one we're going through the specification check and load rating on different types of bridges. AASHTOWare can load rate a large variety of bridge types, including steel girder superstructures, pre-stress concrete superstructures precast shapes, reinforced concrete superstructures, reinforced concrete slab system superstructures, reinforced concrete multi-celled box superstructures, reinforced concrete box culverts, 3D analysis use for multi-girder straight and curved systems, automatic mesh generation with user controls, dead and live loads, transverse live load analysis, or user-defined vehicle loading path. And now the design tools included with AASHTOWare. Substructure design review, including generation of load cases, user-defined load cases, LRFD load combinations, and LRFD spec checking. Substructure design review, including foundation types like spread footings, pile footings, single drilled shaft. Design tools, pre-stressed utilizing shear stirrup design tool, shear stud design tool, and flange to web weld design. The software has extensive load rating capabilities, including post-tensioned concrete multi-celled box superstructures utilizing LRFR, LFR, line girder analysis, full box including web lines, user-defined box cross sections, and integral with piers. Floor system utilizing LRFR, LFR, and ASR. Floor systems utilizing LFR or ASR. Steel trusses utilizing LRFR and LFR. Continuous spans, suspend spans, counters, deck trusses, through trusses. Sawed timber superstructure utilizing ASR, including deck rating. Graphics, verification of input and analysis results. Yeah, nope. I still won't be able to see your screen or what's coming from your camera either.
Okay, so let me see if I can share my screen right. So can you see my face?
Yes. Okay, I think we got it. So, you work for ProMiles, right?
Yeah, right. Yeah. We work with AASHTO in developing AASHTOWare bridge design and rating software.
All right. Go ahead and take it away.
Okay, sounds good. Bridge Explorer displays a list of bridges which are organized into folders. And working with a bridge inside a Bridge Explorer is like working with a file in a file explorer in Windows. A Bridge Explorer also allows you to find a bridge, import a bridge model, batch export a bridge model, or batch export a bunch of bridge models. You can also rate multiple bridges through Bridge Explorer. Library Explorer allows you to define predefined shapes, factors, and vehicles based on standard specifications. It also allows you to define your own shapes and own materials and own vehicles to be used in multiple analysis. Configuration browser allows you to edit users, user groups, and add access privileges. Parameters allows you to edit a certain area where the bridge is located for districts and counties. System defaults allows you to edit default values that will be used in bridge workspace, the line gutter analysis engines or 3D analysis engines that will be used by default, and different factors related to a certain specification. The bridge workspace. You can model your bridge inside the bridge workspace. You can also analyze the whole bridge or individual analysis members through the bridge workspace.
Great. I think we got it.
Being a part of this agency really led software helps, you have input into it so that if there's something you really want to see changed, you have the ability to change it or to add to the software. So that's a very big benefit for states.
In the past, we were having to be very conservative so we wouldn't have some kind of a failure. Why do we have the highway system? It's for mobility. And if we're having to send trucks 100 miles out of the way in order to avoid a bridge, then we want to have justification for doing it, not just because we're a little concerned that it might not make it. That's not the right answer. We either know or we don't know.